Properties of rectangle, rhombus and square. Rectangle has 4 right angles, has all the properties of a parallelogram, has diagonals that are congruent. Rhombus has 4 congruent sides, has all the properties of a parallelogram, has diagonals that are perpendicular, has diagonals which bisect its angles. Square has 4 right angles and 4 congruent sides, has all the properties of a parallelogram, has diagonals that are both congruent and perpendicular, has diagonals which bisects its angles, has all the properties of a rectangle and rhombus. Now coming to solve theorems. Diagonals of a rectangle are congruent. You have to prove that diagonals of a rectangle are congruent. So you draw the figure. You are given quadrilateral ABCD is a rectangle. You have to write that. I have not given here. I have given in the next page. So now just I am giving the gist of it, what you have to do. You are given quadrilateral ABCD is a rectangle. You have to prove diagonal AC is congruent to diagonal BD. And for the proof, you have to show triangle ADC is congruent to triangle BCD. By SAS test, you can show that. Therefore, diagonal AC is congruent to diagonal BD by corresponding sides of congruent triangles, because they are corresponding sides of congruent triangles. Now I have given the explanation in detail now. So consider rectangle ABCD. You are given ABCD is a rectangle. You have to put the quadrilateral symbol before ABCD. Given quadrilateral ABCD is a rectangle, AC and BD are the diagonals of the rectangle. To prove AC is equal to BD. Now coming to the proof. In triangle ABC and triangle BCD, now look at triangle ABC and triangle BCD in the figure. Segment AB is congruent to segment CD. Otherwise, you can write AB is equal to CD. Length of AB is equal to length of CD. Because the reason is opposite sides of a rectangle are equal. Opposite sides of a rectangle are congruent. Now, angle ABC is congruent to angle BCD, therefore measure of angle ABC is equal to measure of angle BCD. Since each equals to 90 degrees, each angle equals to 90 degrees. Segment BC is congruent to segment BC. Common side. Here it is mentioned length of BC is equal to length of BC. If you write segment, you have to not write equal to, you have to write congruent symbol. Segment BC is congruent to segment BC, otherwise BC is equal to BC, common side. You have to write the common side. Therefore, triangle ABC is congruent to triangle BCD by SAS test. It is enough to write by SAS test. That implies AC is equal to BD, corresponding sides of congruent triangles. Or you can write segment AC is congruent to segment BD, corresponding sides of congruent triangles CSCT. Hence, we have proved that the diagonals of a rectangle are congruent. Now coming to the next theorem. Before that, I want to tell you something. You also can prove that diagonals of a square are congruent. diagonals of a rhombus are perpendicular bisectors of each other. One another, it means each other. Diagonals of a rhombus are perpendicular bisectors of each other. Given quadrilateral ABCD is a rhombus, put the symbol, that square symbol before ABCD. You have to prove measure of angle AOD is equal to measure of angle COD. Also you have to prove OA is equal to OC and OB is equal to OD, because you have to prove the diagonals of the rhombus are perpendicular bisectors of one another. So you have to prove measure of angle AOD is equal to measure of angle COD is equal to 90 degrees, and also you have to prove OA is equal to OC and OB is equal to OD. So arrange it accordingly. I have just given a hint how to do it. You can rewrite the proof. Given ABCD is a rhombus, quadrilateral ABCD is a rhombus, you have to prove OA is equal to OC and OB is equal to OD, and measure of angle AOD is equal to measure of angle COD is equal to 90 degrees. Now, coming to the proof. Quadrilateral ABCD is a rhombus, therefore it is a parallelogram too. Like this you have to start the proof. Quadrilateral ABCD is a rhombus, therefore it is a parallelogram also. Since diagonals bisect each other, OA is equal to OC and OB is equal to OD. In a parallelogram, diagonals bisect each other. So OA is equal to OC and OB is equal to OD. Take it as first equation and second equation. This has to come under proof. I have mentioned there because the page will not be enough for writing. Otherwise, we have to go to the next page. That's why I have mentioned the first equation and second equation under given only, but you have to arrange it properly. Now, then you have to mention in triangle AOD and triangle COD, OD is common, so OD is the common side for triangle AOD and triangle COD. OA is equal to OC is given. AD is equal to DC. See, OD is common. You have to write OD is equal to OD. Don't forget to write OD is equal to OD. Within brackets, you have to write common side. Then in the next line, you have to write OA is equal to OC. Within brackets, given. That we have taken as equation 1. Then you have to write AD is equal to DC, sides of the rhombus. You know all the sides of the rhombus are congruent. So the lengths will be equal. So AD is equal to DC. In the next line you write, therefore, triangle AOB is congruent to triangle COD by SSS test. Now find out what is the corresponding angles of congruent triangles. Angle AOD is congruent to angle COD. Otherwise we get measure of angle AOD is equal to measure of angle COD. Now, angle AOD and angle COD are a linear pair, you can see from the figure. Therefore, write measure of angle AOD plus measure of angle COD is equal to 180 degrees. But we have measure of angle AOD is equal to measure of angle COD, which we already proved. So, instead of measure of angle COD, you can substitute measure of angle AOD. So, you get measure of angle AOD plus measure of angle COD. Sorry, measure of angle AOD plus measure of angle AOD is equal to 180 degrees. Therefore, 2 into measure of angle AOD is equal to 180 degrees. Therefore, measure of angle AOD will be equal to 180 degrees upon 2, that is equal to 90 degrees. But we also have measure of angle COD to be equal to measure of angle AOD. So, measure of angle AOD is equal to measure of angle OD is equal to 90 degrees. Take it to be third equation. So all these intermediate steps you have to write because you have learned so many theorems, so it is a homework for you to write. So now combine equations 1, 2 and 3. From equations 1, 2 and 3, we prove that the diagonals of the rhombus are perpendicular bisectors of one another. From equations 1 and 2, we can understand that bisector part. And from equation 3, we can understand the perpendicular part. So, we have proved that the diagonals of a rhombus are perpendicular bisectors of each other. Now coming to practice set 5.3 in page number 69. See question number 1. Diagonals of a rectangle ABCD intersect at point O. If AC is equal to 8 centimeters, then find BO, and if measure of angle CAD is equal to 35 degrees, then find measure of angle ACB. You have to write of the pattern given and to find. Then solution. Given diagonals of a rectangle ABCD intersect at point O. AC is equal to 8 centimeters. Measure of angle CAD is equal to 35 degrees. To find BO and measure of angle ACB. You have to draw the figure. Figure is not given. So you have to draw the figure. Mark everything what is given. Diagonals of a rectangle. You know that diagonals of a rectangle are congruent. So AC is equal to BD. Length of AC is equal to length of BD. You are given AC is equal to 8 centimeters. So BD is also 8 centimeters. So AC is equal to BD is equal to 8 centimeters. You have to write within brackets since AC is equal to 8 centimeters given. Also rectangle is a parallelogram. So the diagonals bisect each other. Therefore BO is equal to OD is equal to 4 centimeters. That will be half of 8 centimeters. So it is 4 centimeters. Now AD is parallel to CB. AD is parallel to CB since ABCD is a rectangle. And we are going to take AC as the transversal, line AC to be the transversal. So you get the alternate interior angles to be angle CAD and angle ACB. So they are congruent. Alternate interior angles are congruent. So the alternate angles are congruent. So measure of angle CAD is equal to measure of angle ACB is equal to 35 degrees. Since you are given that measure of angle CAD is equal to 35 degrees. Now coming to question number 2. In a rhombus PQRS, if PQ is equal to 7.5, then find QR. If measure of angle QPS is equal to 75 degrees, then find the measure of angle PQR and measure of angle SRQ. So this you have to write of the pattern given and to find, then solution. Figure is not given, you have to draw the figure and label it properly. Now write the solution. All the sides of the rhombus are equal. So PQ is equal to QR is equal to 7.5 centimeters. Since you are given PQ is equal to 7.5 centimeters. So QR also will be 7.5 centimeters. A rhombus is also a parallelogram. So measure of angle QPS is equal to measure of angle SRQ because opposite angles of a parallelogram are congruent. But you are given measure of angle QPS is equal to 75 degrees. So measure of angle SRQ is also 75 degrees. You can write in the next step, take it in the next step and write the reason also beside it since measure of angle QPS is equal to 75 degrees within brackets. That is given. Now also a rhombus, we have the parallel lines and the transversal, then we get the interior angle. So you have to write that statement. I am just given the hint. You have to write that properly. You are taking PS parallel to QR now because it is a rhombus. Opposite sides are parallel and the transversal as PQ, line PQ. Then we have the interior angles. Interior angles on the same side of the transversal are supplementary. So we have the interior angles as angle QPS and angle PQR. Interior angles are supplementary. So measure of angle QPS plus measure of angle PQR is equal to 180 degrees. Now substitute the value of measure of angle QPS. Measure of angle QPS is 75 degrees. Write 75 degrees plus measure of angle PQR is equal to 180 degrees. Therefore, PQR will be equal to 180 degrees minus 75 degrees, which is equal to 105 degrees. Write all the steps. Question number 3. Diagonals of a square IJKL intersects at point M. Find the measures of angle IMJ, angle JIK and angle LJK. Here also you write what is given and what is to be found out. Given diagonals of a square IJKL intersects at point M. To find the measures of angle IMJ, angle JIK and angle LJK. Then write solution. Draw the figure. Right, diagonals of a square are perpendicular bisectors of each other. So measure of angle IMJ is equal to 90 degrees. A square has all the 4 angles as right angles. Also, diagonals of a square bisect the opposite angles. So measure of angle JIK will be equal to half of 90 degrees because diagonals of a square bisect the opposite angles. Half of 90 degrees is otherwise 45 degrees. Similarly, you can find out measure of angle LJK. Diagonals of a square bisect the opposite angles, so it will be equal to half of 90 degrees. So that will be equal to 45 degrees. Now coming to question number 4. Diagonals of a rhombus are 20 centimeters and 21 centimeters respectively. Then find the side of the rhombus and its perimeter. Given diagonals of a rhombus ABCD are 20 centimeters and 21 centimeters. AC is equal to 20 centimeters and BD is equal to 21 centimeters. To find the side of the rhombus, let us find AB. To find side AB, actually you have to find all the sides, but all the sides are equal. So you can write to find the side of the rhombus and its perimeter. So first of all, we will find one of the sides AB. Then we will add it 4 times, otherwise multiply by 4. Then you will get the perimeter of the rhombus. So try the solution. Let ABCD be the rhombus. Put the symbol quadrilateral before it. Let quadrilateral ABCD be the rhombus. AC is equal to 20 centimeters and BD is equal to 21 centimeters. We know that the diagonals of a rhombus bisect at right angles. So, first we have to write the bisecting parts. AO is equal to OC is equal to 10 centimeters and BO is equal to OD is equal to 10.5 centimeters. Then in the next line you have to write in triangle AOB. I have not written something. You have to write in triangle AOB, measure of angle AOB is equal to 90 degrees. Therefore, triangle AOB is a right Now substitute the values here. 10 square plus 10.5 square is equal to AB square. 10 square is 10 into 10, that is 100. 10.5 square is 10.5 multiplied by 10.5, that is 110.25. So 100 plus 110.25 will become 210.25. Now find the square root of this. You know to find out the square root division method. You are learned in 8th standard, so you can use that and find out the square root. You will get 14.5 centimeters. Thus, each side of the rhombus is equal to 14.5 centimeters. Therefore, perimeter of the rhombus will be adding all the four sides AB plus BC plus CD plus DA. That is equal to 4 multiplied by 14.5, which is otherwise equal to 58 centimeters. Question number 5. State with reasons whether the following statements are true or false. Some statements are given. You have to state whether the following statements are true or false and give the reason. Whether it's true or false, you have to give the reason. So, coming to the answer. First one, every parallelogram is a rhombus. Answer will be false. Every rhombus is a parallelogram, but the vice versa is not true. I have taught it in some class before. So you can write it. Now, coming to the second one, every rhombus is a rectangle. It is false. Answer is false. As in a rectangle, all the angles are right angles, but the same is not true in a rhombus. Now coming to the third one, every rectangle is a parallelogram. Answer is true. All rectangles have the opposite pair of sides congruent and parallel, and the diagonals bisect each other. So every rectangle is a parallelogram. Because for parallelogram, that is the property is matching with the parallelogram. So every rectangle is a parallelogram. Every square is a rectangle. True. As all the angles are right angles and the diagonals are congruent to each other. We also know these are the properties which are coming under rectangle also. So every square is a rectangle. Now coming to the next one, fifth one. Every square is a rhombus. It is true. As the diagonals of a rhombus are perpendicular bisectors of each other, and they also bisect the pair of opposite angles. So every square is a rhombus. All the properties of the rhombus, if you take, they are matching with the square. So every square is a rhombus. Now coming to the next one, sixth one. Every parallelogram is a rectangle. That is false. As in a parallelogram, the opposite angles are congruent but not right angles. In a parallelogram, the opposite angles are congruent but not right angles. So every parallelogram is a rectangle is false.